Hello, welcome once again back to our discussion about drying operation under the course Mass Transfer 1. So this is our 7th class. In the 6th session, we studied about rotary dryer, its construction, working, applications, advantages and disadvantages. And we also learned what is meant by a vacuum tray dryer. So today's class, let us take up the rotary dryer to understand its construction, working types, as well as advantages, disadvantages, and applications. So, rotary dryer is that type of dryer which may be either directly or indirectly heated and adapted for usually continuous drying operation of free flowing granular materials on a large scale. So, this is one type of dryer which can be utilized on a large scale drying operation, and it may be directly or indirectly heated. At the same time, it can be used for a continuous drying operation. Okay, so this is a simple sketch of a rotary dryer in which you can see it mainly consists of a cylindrical rotating drum, so that is supported on a rims like this, so which in turn are supported on the pinion rollers, then the thrust wheels which are provided to avoid the slipping of the rotating drum on the thrust wheels. So it is driven by the gear mechanism like this. So it is connected to a motor here. So whenever it is direct heated, then the feed and the hot air both flow through the drum, being in direct contact with each other. So since this is a countercurrent flow rotary dryer, the feed, if it enters this side, the air enters from the opposite side. Both flow in countercurrent fashion with respect to each other. Then the air along with the evaporated moisture goes out from the feed end, and the product, that is dried product, gets discharged from the opposite end. Okay, so this is the side view of the rotary dryer, and this is how the inside view looks like. So the outer periphery of the cylindrical drum from the inside is fitted with these kinds of lifting devices called flights. So they help in lifting the material to the top, and from there showering it down into the gas stream, thereby establishing a proper contact between the material and the drying medium, so thereby help in reducing the moisture content to the required extent with the minimum utilization of energy. So this is a 3D view of a rotary dryer. So this is the feed end, the drive gear mechanism, then supporting rims, the horizontal cylindrical shell, and this shell will be inclined at an angle with the horizontal. So let us understand its construction. Figure shows directly heated rotary dryer, and it consists of a long cylindrical shell of about 1 to 3 meter diameter and 3 to 30 meter length, set with its axis at slight angle to the horizontal. The shell is mounted on rollers so that it can be rotated. To avoid it slipping over the rollers, thrust wheels are fitted, so as it is shown in the diagram. Inside it, inside it is fitted with flights which lift the material upward and shower it down from the top. A few spiral flights are fitted near the feed end, which help in giving the initial forward motion to the material before the principal flights are reached. So, just at the feed end, We can see some of the spiral flights that will help the material to advance in the forward direction before the material reaches the principal flights as shown here. So coming to the working of rotary dryer, the material to be dried is fed at the high end and then by a hopper. Product is taken from the lower end. The material moves to the dryer by the virtue of rotation, heat effect and inclination of the cylindrical shell. So the forward movement of the material from the feed end to the discharge end is supported by the rotational action of the cylindrical shell and also the heat effect and the inclination of the cylindrical shell to the horizontal plane. The cylindrical shell is rotated by gear mechanism at a speed of 2 to 25 rpm. Air is taken into the dryer from the product end, is heated in a heater, then moves through the dryer in a countercurrent fashion with respect to material to be dried. So this is the air flows. It is sucked in from the discharge end of the product and it passes through a heater where it gets heated and in the form of hot air it flows in this direction in countercurrent fashion with respect to material to be dried. Due to heat transfer because of direct contact with the heating medium and the wet material, the moisture from the material evaporates and that evaporated moisture is carried away by the air and finally with that moisture content it goes out from the feed end. A simple diagram showing you how the rotary dryer works. So this is a parallelly operated rotary dryer means the hot air and both the wet product enter the dryer from the same end and due to rotation they'll flow in the same direction and when they come to other side the solid material goes out as dried product and the hot air along with the evaporated moisture goes out as the waste gas. Okay, so this pic shows how the side view of a rotary dryer looks like. So these are the spiral plates which help in moving the material in the forward direction and these are the lifting flights. So these will be fitted at a certain distance from the feed end. So near the feed end what you find is the spiral flight. So you can also see here how the flights are carrying the material to the top. From there it is dropping down the material to the bottom. Okay, so this is a simple flow diagram showing you how the air draft is provided to a rotary dryer. The air will be sucked in by through the rotary dryer by means of a fan and the air going out usually contains dust particles of the product. So since this is a direct heated dryer, the direct contact between the air and the product occurs inside the dryer and during that time it tends to carry away some of the very fine particles of the product. So these particles can be removed from the air going out of the dryer by interposing a cyclone separator between the fan or blower and the rotary dryer. Okay, so cyclone collects all the dust particles going out with the air and the clean air along with the moisture goes out, gets discharged at this point. Okay, so exhaust fan is used to pull the air through the rotary dryer. The air leaving the dryer will contain dust particles that are removed by interposing a cyclone separator between the dryer and the exhaust fan. In case of indirect rotary dryer, heat is transmitted through a wall of the cylindrical shell. So indirect dryer means the one in which there is no direct contact between the heating medium and the material to be dried. So in that case, the heat is transferred to the material through metal wall by conduction mode. Okay. So later we'll see how an indirect rotary dryer works. So let us now just go through few advantages, disadvantages, and applications. Okay, advantages of a rotary dryer. We can establish good gas contacting with the material to be dried. Then the time of drying is moderate, is not very long. So its initial cost, low capital cost, that is initial cost is less. Thermal efficiency is high. So flexibility to control the gas velocity is greater. Coming to the drawbacks. So difficulty of sealing. So product may be built up on the walls. High structural load and non-uniform residence time. Okay, so this is a real pic of a rotary dryer. The bottom picture shows a sketch of how a rotary dryer is constructed and operated. And in this case, it is a hot flue gas that is used as a drying medium. And you can see this is the feed end, and these are the spiral flights. And after a certain distance, you can see the lifting flights are fitted. Yes, this is another view of a real pic of rotary dryer. So you can see this is how the spiral flights look like. After this spiral flight are present up to certain distance, then you can see the lifting flights. So you cannot see the lifting flights in this diagram. So you can just make out the spiral flights. Okay, so this is a place where a huge rotary dryer has been installed. This is the rotating cylindrical drum, cyclone separator, the air outlet. Another picture of rotary dryer operated at a large scale drying operation. Okay, let us now understand the construction and working of some of indirect heated rotary dryer. So one such rotary dryer is shown in the figure. It is used for materials which can be used to high temperatures out of contact with the flue gas such as white pigments, etc. It is shown in figure. So the heating medium in some cases is the flue gases, because in that case you require to heat the material to a very high temperature. Also, if the product is such that if it is brought into contact with the heating medium directly, its physical properties will be lost. So in such cases, this kind of rotary dryer can be used, which is called indirect heat rotary dryer. So one such a type of dryer is shown here. This is the combustion space where fuel is burnt, producing flue gases. The flue gases at high temperature then passes in the middle space of the rotary dryer. At the same time, the feed admitted from the same end will flow outside this space, that is in the tube provided around the central space well, which is meant for flue gas. Okay, so here the heat from the flue gas gets added to the material flowing in the annular space by passing through the metal wall of the tube. So in that way, the direct contact between the flue gas and the material is avoided, and that helps in keeping the physical properties of the material intact. So, for example, white pigments may lose its property when it comes in contact with the flue gas. So this is where you need to use this type of indirect heat rotary dryer. So flue gas flows up to this point and then it gets diverted to flow in this space. So that way it is coming into contact from both the sides of the tube in which the material is flowing. Okay, so this is partly uh, parallel current and partly counter current rotary dryer. Okay, so this is another pic of a indirect heat rotary dryer. So another type of indirect dryer is a steam tube dryer employing a number of steam tubes as shown in figure. So if this is the cylindrical shell from the side view, this is how a number of tubes are provided just near the wall through which steam can be passed. So the feed as usual will be flowing through the cylindrical shell. However, even though it is getting heated, it is not in direct contact with the heating medium, that is steam, which is flowing inside the steam tube. Okay. So rest of the construction is similar to the earlier design. Okay. So this finds application where the material to be dried must not be heated to a very high temperature. For example, in case of drying of cattle feed. Okay, so here the temperature of the product is not too high. Okay, so this is another pic showing you the operation of a indirect heat rotary dryer. Feed enters here, flows in this direction. Then air enters here, flows in upward direction. The air goes out from here, the product from this side. So this is a view of a side view of actually the steam heated rotary dryer. You can see the steam tubes running, and this is the space where the material advances from this end to the opposite end. So today we learned what is meant by a rotary dryer, how it is constructed and how it is operated. So how there are different types of rotary dryers like direct heated, indirect heated rotary dryer. What are its advantages, disadvantages, and what are its specific applications? Okay, so time now to take up a test by going through a set of MCQs. Calcium ammonium nitrate is dried in a rotary dryer because rotary dryer is the one which is suitable for granular material and most of the fertilizers are produced in the form of granules. So option E is the right answer. So rotary dryer cannot handle dash materials, free flowing, dry, sticky, granular. Okay, since rotary dryer is meant for granular materials, so the last option is the right, is the incorrect answer. Also, it can handle free flowing dry material easily. So the answer for the question is option C, the sticky material. Flights in a rotary dryer are provided to lift and shower the solids, thus exposing it thoroughly to the drying action of the gas. Reduce the residence time of solids, increase the residence time of the solids, none of this. Okay, so flight's main objective is to establish a thorough contact between the drying gas and the wet feed material. So option A is the right option. Sticky materials cannot be dried in a dash dryer. Tree dryer rotary dryer, fluidized bed dryer, none of this. Okay. So comparatively, sticky material is most unsuitably handled in a rotary dryer. So the right option to answer the question is option B. Free flowing granular materials can be best dried in a, it is of course rotary dryer. So let me end the class with that. So let us again take up another type of dryer in your next class. Till then, take care. Goodbye.